In this video, I'm going to explain a problem similar to the one in the homework, where we're going to find the zeros of this function and then determine the effect on the graph at those respective places. So first of all, to identify the zeros, again, we're trying to determine when will these factors or when will this polynomial equal 0. So if we look at each respective factor, which is at x to the third power, see when is that's going to equal to 0, when the x plus 9, when is that going to equal to 0, and when does x plus 4 equal to 0. So I look at each individual factor and I set it equal to 0. Well, for the first one, that's already solved. The solution to that is 0, so x equals 0. And for the last one, I can get the last one by simply moving the 4 to the other side, making it negative 4. So that's my second intercept. But for this one right here in the middle, 2x plus 9, when is that going to equal to 0? I will solve this equation by moving the 9 to the other side, which is negative 9, then divided by 2. We get that x equals to negative 9 divided by 2. So there's their third one, negative 9 divided by 2. So let's determine again the effects on the graph at those respective places. Beginning with the one on the, we'll start from left to right, negative 4. So x equals negative 4. Since that one right there, we're going to see that that again has a multiplicity of 1, okay? So because this has a multiplicity of 1, the effect on the graph is that the graph of f is going to intersect the x-axis at that location. So we're going to intersect the x-axis at negative 4. So this is our answer. This over here on the right of that, I'm sorry, on the left of this is just a justification of why it's doing that. But our answer is that the graph is intersecting the x-axis at x equals negative 4, and the reason for that is because of the multiplicity of this 0. Since it's an odd multiplicity, it's going to intersect. Now the next one is negative 9 over 2, which is negative 9.4. Actually, I think that one should have probably been done first. Negative 9.5, negative 9 divided by 2. Yeah, and this should have been done first. The multiplicity for that one is 4, because we got this solution by looking at this factor set equal to 0, and because it's raised to the fourth power, the multiplicity is 4. Well, what's the effect of that being an even number? The effect of this number being even is that the graph is going to be tangent to the x-axis at that location. At that location of negative 9 divided by 2. And then finally, we have our last intercept, our last 0, which is 0. And since that one we got from this factor, we got that solution of x equals 0 from this factor, and that's being raised to the third power, the multiplicity is 3. And just like the first one, because that's an odd multiplicity, this is an odd multiplicity, the effect that it's going to have on the graph is that at that location, the graph is going to intersect, meaning it's going to move across the x-axis at that value. So if you don't want to use the word intersect, you could describe it again as saying that it crosses the x-axis. If that's a little bit more nuanced for you, you could use that term there. Because I know when we say it intersects, it can be kind of confusing because, well, all of these are considered as x-intercepts. So we kind of see that the word intercept correlates again to intersection. But in this term here, when I'm referring to something as intersecting, or at least the graph intersecting, I'm saying that it moves across the x-axis. So we have again our plane, this is our x-axis, in these locations of negative 4, over here at negative 4, and at 0 at this place right here, the graph is going to cross through the x-axis. Maybe not from the bottom to top, maybe it could go from the down to below, but top to bottom, we could do that. And then the same thing over here from underneath it to above it. But it's going to actually go through it, and the term intersect, move across the x-axis. So that concludes again the example, and I hope this was helpful.